All right, let's go look ahead and look at these two functions. They're exponential functions because my variable or unknown is part of the exponent. Both of these are simplistic, straightforward exponential functions with not much going on. Note though, there's going to be one difference here. This value, my base value, is greater than 1, and this value is between 0 and 1. That's going to make these two behave a little differently. So let's graph this one. Let's start by doing some ordered pairs here. So let's just start with 0. So when x is 0, that would make, well, 7 to the power of 0. Anything to the power of 0 is 1. So that's going to be my ordered, my y-intercept. It's going to be about 0, 1. Let's plug in 1. 7 to the power of 1 is 7. So 1, 7. We're just going to do kind of a sketch. 1, 7. If I did 2, well, 7 to the power of 2 is going to be 49. This is going to start increasing exponentially here. So what I know is it's going to start really going up pretty rapidly. Even if I did 3, if I think about 3, well, 3, 7 to the power of 3, or 7 to the power of 4, those are going to start being big, big numbers. So this is going to start increasing really rapidly. Let's try now, let's do -1. See what happens on this side of my graph. So if I did 7 to the power of -1, let's just come down here and do that. 7 to the power of -1 is actually 1 over 7 to the power of 1, or 1/7. So when x is -1, y is 1/7. So that would be -1, 1/7 would be just a little bit above 0. Let's do -2. Well, -2 is going to be 7 to the power of -2, or 1 over 7 to the power of 2, which is 1 over 49. So when I plug in -2, whoops, that's not what I wanted, I get 1 over 49, which is going to start getting me closer to 0. So -2. And what I'm going to find here is, if I plug in 3, well, that's 7 to the power of -3, which is 1 over 7 to the third, which would be 1 over 243. So these numbers are going to keep getting smaller and smaller and smaller, but they are never going to get below 0. All right. Even if I plugged in like -1000, well, -1000 would be 1 over 7 to the 1000th. 7 to the 1000th is going to be a huge number, but it's still 1 over that. So this graph is going to be approaching 0, but never crossing. So that is the graph for y equals 7 to the power of x. Let's come over here, y equals 1/4 to the power of x. So if I plugged in 0, 1/4 to the power of 0, it's going to be 1. Once again, my y-intercept is 1. If I plug in 1/4 to the power of 1, well, 1/4 to the power of 1 would be 1/4. So 1 and 1/4 would be right about there. If I plug in 2, so 1/4 to the power of 2 would be 1/16. And it's kind of a reverse. As I'm going this way, it's going to keep getting closer and closer to 0, but it is never going to get to 0. Let's look at my negatives. So 1/4 to the power of -1. Kind of distributed property, so this is 1 to the power of -1 and 4 to the power of -1. And because they're negatives, I have to flip-flop them. So 4 over 1. So when x is -1, y is 4. So -1, 4, about here. I'm going to find when I plug in -2, it's actually going to be 16. And it's increasing exponentially this way. So those are the two graphs. The difference here is when I have a number greater than 1, it's going to be increasing exponentially. And when my value is between 0 and 1, it's going to be decreasing exponentially.